Welcome to this quick start tutorial for Phoenix FD for Maya. In this video, we look at creating a liquid simulation using a quick preset, and then rebuild it manually to understand it more fully. Now we'll start in a blank scene, and I'll create a sphere that will be the source of my liquid, placing it like so. With the sphere still selected, I'll choose the tap water preset from the Phoenix FD shelf. Now select the Start Simulation icon. The liquid simulation begins pouring down from the sphere and interacts with the walls of the container to fill it up. Click Stop to halt the simulation. Let's render to see how this looks. So first I'll switch over to V-Ray in the render settings. Now all I need is a light in the scene. Change to the V-Ray tab in the shelf and add a dome light. And in the attribute editor, set the dome light to be invisible, and go ahead and render the frame to have a quick look. So we did that pretty easily by using the tap water quick preset. Now let's take a look at setting this up manually to have more control and to really understand the workflow. Select the liquid simulator and delete it. Also, select this node, the source, and delete that so we can start fresh. In the Phoenix shelf, click on the Create Phoenix FD Fluid Simulator icon and click and drag to create a volume shown here in the pink colored lines. The existing fluid from before is in the blue-green colored line. We see the former simulation since it's still in the system cache. Click the trash icon here to delete the cache and click Yes to confirm. Now I'm just left with the new simulator, and I'll move the sphere up to the top of it. Check the sphere's radius and take note that it's about 4 units, so I'll actually set it to 4 exactly. Scale is an important aspect to these simulations. We can see that Maya is currently set to centimeters. Now you can use whichever units you prefer, just make sure your objects are in the correct world scale for the most correct simulations. Select the simulator, and in the attribute editor, expand the grid section, and you can see the size of the simulator here, 134 by 147 by 240 centimeters. Now this size is affected by the unit's scale value that lets you cheat the scene scale to create smaller or larger sims. As I adjust the unit's scale, cell's size changes to reflect the new scale. Quick presets, like the tap water we just used, set this value for you. We'll go ahead and leave this at 5. Now we need to have a liquid source. Click Create a Liquid Source icon in the shelf and place the source in your scene. Select the sphere and then Shift select the source and click Add Selected Objects in the attribute editor to add the sphere as an emitter for the liquid. The source node is where we control the fluid's discharge settings, and the sphere is the actual emitter of the fluid inside the simulator. Select the simulator, and in the liquid section, click Enabled. Click the Start Simulation icon, and you'll confirm that the sphere is indeed emitting the liquid inside the simulator. This time the sim is mostly white, so let's go ahead and change that. Select the simulator and expand the preview section and scroll down to the particle preview. The faster the particles are moving, the whiter they will be. So we will offset the white speed value to make it higher. That introduces more of the blue preview color into our simulation whenever the particles are not traveling quite as fast. Set this value to about 730. Now, let's get this to look more like what we had with the original preset. The edges of the simulation are a bit jagged. Expand the dynamic section, and at the bottom, adjust the steps per frame to 12, and after letting the simulation run a bit, that should fix the ragged edge effect and help smooth the shape of the pour. This provides for a more natural look, but will make the sim run slower. The higher the steps per frame, the longer the calculations, so try to find the lowest setting for the effect that you need. As you can see, the liquid is flowing right through the floor and disappearing. This means that our simulator is open and needs to be closed. I'll close these sections and open the grid section. In grid, under boundary conditions, set the X, Y, and Z axes to jammed both. As the simulation runs, the liquid will now collide with the bottom and the side walls of the simulation container. It is, however, running quite slowly, so we can adjust the resolution to address that by increasing the cell size. Now, first take note that we have about 4.7 million cells to calculate in the sim, and this is our simulation's resolution. Setting the cell size sets the size of each cell inside that container, and consequently, how many cells are inside the simulator, thereby adjusting the resolution. Stop the sim and increase the cell size value. The larger the cell size, the lower the simulation resolution, which will make it run faster. Set the cell size to 0.5 and start the simulation, and you'll see it's running much faster now. Try rendering a frame to see it in the V-Ray frame buffer, or VFB. It has a solid gray look to it that we will now replace with a better water material. Stop the render and open the hypershade and create a new V-Ray material. Now make sure your material viewer in the hypershade is set to V-Ray so that we can preview the material as we create it. Set the diffuse color to black, then set both the reflection color and refraction color values to white. Change the refraction IOR to 1.33 to better represent water, and then toggle Effect Shadows to be on. Then simply assign this new material to the simulator object in the scene. Click the Render button and you'll see that the simulation takes on a more natural water look. Now let's take a look at how to make this liquid collide with and fill an actual object. Here I have a scene with a jar in this studio lighting setup with a background. This file is provided in the tutorial's downloaded assets shown below. Switch your view to camera 1 and render to see a solid gray jar and background. Now back to the perspective view and select the sphere. In the Phoenix shelf, choose the Tap Water Quick preset like we did before. Now it creates a simulator, but we need to adjust it. Move the simulator to fit around the jar and use the X, Y, and Z size attributes to size the simulator shape to have a little space between it and the jar. Now, using these attributes, as opposed to simply scaling the simulator with Maya Scale tool, also changes the simulator resolution to give the simulation more detail as needed in larger containers. Start the simulation and switch to the camera 1 view. To get our jar to be glass, select it, and in the Attribute Editor, select the Glass tab, which represents the V-Ray material assigned to the jar. Set the diffuse color to black, and check to make sure that the reflection color is white, and then set the refraction color to white as well. The mesh will seemingly disappear in the viewport because now it's fully refractive. Render a frame to see how the fluid is interacting with the jar. Now, any geometry that you put inside a simulation will automatically interact with the emitting fluid. You can, of course, exclude geometry from interacting in a simulation, and you can even create non-solid geometries. Now, these are geometries that a simulation can flow right through, but they can still be used as sources or forces acting on the simulation. Now, these we'll discuss in upcoming videos. Now look at the sim and it will fill and eventually overflow the jar. Stop the sim. Select the liquid source object and look at the discharge value. This value sets how much fluid is being discharged by the emitter, and so animating this attribute will control how much liquid is being created. So at the beginning of the scene, if I set discharge to 0, nothing gets emitted. I'll set that back to 16. Now, go to frame 22 and I'll key this value at 16. At the next frame, at frame 23, I'll key discharge to 0 to stop the pour at that time. Now start the simulation and have a look. Once you stop the simulation, you can scrub the cached sim and evaluate your scene. Now pick a frame and go back to camera 1 and try rendering to see how this looks. Here I'll play back for you the rendered result of this entire sim. Notice, however, that the fluid is making some drops hit the sides of the simulator walls. Let's go ahead and make this pour nice and straight. We can see here that the pouring liquid gets fairly spread out. Also, the emitter is bumping up against the top of the container a little bit as well. So let's move the sphere down a little bit, then select the simulator, and in the grid section under the boundary conditions, set the X, Y, and Z walls to be open. This will keep any of those droplets from colliding with imaginary walls. Then go to the liquid section and set the consumed liquid attribute to 0. This also relates to the wetting parameter, which creates these red particles we see wetting the inside of the jar, creating a wet map. By setting consumed liquid to 0, we are preserving all the liquid with none of it evaporating away. So now let's fix the spreading out of the pour as the emitter stops discharging. Select the liquid source node and change the emit mode to volume brush. What this means is that instead of emitting the liquid from the surface area of the sphere, it will now emit from the whole volume of the sphere. Now select the emitter sphere, and in the extra Phoenix FD attributes for the shape node, turn off solid. This means the sphere geometry itself will not interact with the liquid simulation like the ball under pouring water. Start the simulation, and you can see that the liquid is coming from the volume of the sphere now, as opposed to just from the outside surface. Stop the sim when the jar is getting filled up and scrub back and forth to see the pour nicely contained even after the discharge value turns off at frame 23. Render the result from the camera 1 view and you should have a nice jar of water just like this. Thank you for joining us for this quick start video on liquid simulations using Phoenix FD for Maya.